So next, configuring a single combined deployment. So in this, let's see the configuration of the single combined meeting server deployment. So firstly, there is encryption. To understand that encryption and security is as an aspect very important prerequisite for CMS. So in encryption, two types of encryptions are there, symmetric and asymmetric. So both are supported. So symmetric encryption gives you benefits like it is fast for sending a large amount of data. Disadvantage is that the encryption key must be installed at both the ends of the communication. Yeah. So symmetric encryption involves encrypting, decrypting the data with the same key. So before the data is transmitted, it has to be encrypted with a key. And once the data is received at the far end, it is then decrypted with the same key. This form of encryption is ideal for collaboration because it is fast, so it can be for real-time communications and it can be used for sending a large amount of data, for example, video. The challenge with symmetric encryption is how to get the same key at both the ends of the communication. That is a part of the encryption here. Then we have asymmetric. This is what we just discussed, some benefits and disadvantage. It has to be enabled on both ends. Okay, then asymmetric. Asymmetric has the use of two keys. So a public key, which is advised to anyone. Any one of the end must have a public key and a private key only known to the device receiving the message. Yeah. So a public and private key can be used here, and a private key is only known to the device which is receiving this message, so that using that private key, it can uh, decrypt it. And then the message encryption with the public key can be decrypted only with the matching private key, or vice versa. So with asymmetric encryption, you use these set of keys, private and public. Data is encrypted with the private key. So with the help of private key only, it is decrypted then. So the reason the keys are called private and public is that when a device creates these keys, it keeps one of the key private on the device. That's called a private key, and it publishes the other public key, yeah, to any other device trying to communicate with it. Like they're using code that I know my code, you tell me my code, what is it? So like that. And it publishes the public key to the other. And once they exchange the public keys, they have to decrypt using the private keys, which are common but not shared. Then there's authentication. Authentication is again very important for certificates, and their certificates are used for authentication to provide proof that you are who you are. Uh, that is what authentication is. For getting a certificate, we need to have a certificate signed by CA. In production, it is always recommended to get it signed by a public CA, but in our lab environment, we can create our self-signed certificates. That's what we are going to do. So for getting the certificate here, we can see the flow. First is certificate signing request, which we saw earlier also. The same is the process here. So we get the certificate signing request. Then the CA investigates to ensure